Hello, in this video, I'm going to show you how to solve this problem. As we all know that the firing of a bullet is one of the practical example of inclined motion. Okay, so this is a practical example. So I'm going to show you how to handle this type of problem. A bullet is shot horizontally from shoulder height 1.5 meters with an initial speed 200 meters per second. 1. How much time elapses before the bullet hits the ground? 2. How far does the bullet travel horizontally? Taking G to be 9.8 meters per second square. So this is a diagram for the question that we have. Since the bullet was shot horizontally, it means it is not an inclined projectile motion, but horizontal projectile motion. And in this case, the angle of inclination is going to be 0. Theta is going to be 0 because it is not inclined, it is just horizontally. And then the initial velocity along the y component, here is going to be 0, but the initial velocity along the x components, this is going to be 200, which is given to us. So let's quickly write out what we have in this question. So we have the height, which is given as 1.5 meters. We have the initial velocity along the x component, which is given as 200 meters per second. And then we have what again? So theta in this case, we say 0 degree. And then what else? We have G, which is given to us as 9.8 meters per second squared. So the first question says, how much time elapses before the bullet hits the ground? This is the same thing as the time of flight, but in horizontal projectile motion, the time of flight is given as T equal to the root of 2h divided by g. Now we just plug in the information that we have in this question. So we have 2 times height, which is 1.5, and then divided by gravity, which is given as 9.8 meters per second square. Everything is inside the square roots. Now 2 times 1.5 is 3. 3 divided by 9.8, do not forget the square root. So when we divide 3 divided by 9.8 and then we take the square root from the calculator, we have the time, which is 0.553. Therefore, we can say the time of flight or the time taken is 0.553 seconds. So this is the time. The second question is, how far does the bullet travel horizontally? Which means from the point of projection, the point at which it was shot, to the point at which the bullet hits the ground surface again. So the distance, which is the horizontal range. So let's call this point X, and then I'm going to use this formula. So X is equal to this, then cos theta multiplied by the time. So we plug in what we have. The initial velocity along this path is given as 200 multiplied by cos theta. So let's just say cos 0 degree in this case, multiplied by the time given to us, 0.553. That is what we found. And then x equal to 200 times cos 0 is always 1 times 0.553. So when we multiply 200 times 1, of course, it's 200 times 0.553 from the calculator. We are having, if you want to approximate to a whole number, we are going to say 111 meters. So x is 111 meters, the horizontal range. So this is how to solve this type of projectile motion problem. Thank you for taking your time to watch this video. Please do like it, share it with more students, and if you're not following this page, endeavor to do so for more updates. Thank you.